see our presentation. Today we will see about analysis of magnetic field to electric current. Before we start, let us introduce our member to you all. My name is Nila Fadila Pisma Fasiho and my number is 43274.
My name is 43274. Nila.
Number 430 and 29.
430 Warisan ya?
My name is Wahyu Nugraha. Number is 4039.
Wahyu ya?
And my name is Ahmad Arif Fikri. My number is 43025.
35 Hah? 25 Ahmad ya? Arif Fikri ya?
First, we focus in case study is extra high voltage transmission line, or we call it in Indonesian sutet. You know sutet? Yes.
No.
Let's start the presentation. First, so what we are going to talk about? First, we will talk about the description of the problem, and the second is evaluation of the problem. Then, before we go to resolve the numerical method to solve the problem. And for the first presenter is Mila.
Okay, I want to describe about our problem. Electrical transmission is the movement of electrical energy from the negative side, such as a power plant to an electrical substation. The interconnected wire, which just facilitate this movement, are known as transmission network. It is distinct from the local wiring between high voltage substation and customers, which is typically referred to as electric power distribution. And I want to description about SUTEP. SUTEP is the transmission channel is the medium used to transmit power from the generator station or power to distribution station up until customer power users. Electric power is transmitted by conductor type drain electrical transmission line. But remember that the current carry wire, there will be a magnetic field like with cable wire, high voltage wires, which are very large. Current is applied. The magnetic field will be infinitely rise.
The focus of the problem is in the magnetic field that caused by the electric current. Now, from the lesson, we know that.
Balik. Sebelumnya. Nah. Lagi. Tadi sudah ada satu tingkatan. Kayak ada problem bukan ini. Yang tadi tingkatan lain ya. Oke, itu ya.
Question. Where the
When the battery is low. Ini untuk presentasi khusus untuk angkat khusus ini ya. Kenapa nggak dipindah?
ya tidak kuat.
Oh Ya. Bisa dibuka di situ.
Where the V is the number, the value of the magnetic field. Yeah, this is the equation, the integer, and then go to this one. Now, from this equation, we can get ways to solve. The first analytical method with this equation, when the mu is the permeability, and E is the electric current, and R is the radius of the wire.
So, from the general equation, this we can divide this equation to two equations, numerical method. The first is trapezoidal rule, and the second is Simpson's 1/3 rule. And this trapezoidal can get from integration of this general equation. Yeah, we can get the trapezoidal rule is caused by trapezoidal integration, trapezium under the circle, under the function of fx. Then we can get this equation. E is equal B min A. Terus next. Nah, we can get this equation. Terus next. So this is the equation of trapezoidal rule. And then the second is Simpson 1/3 rule. Simpson 1/3 rule is same like trapezoidal, but trapezoidal have one order and Simpson have two order. So at least trapezoidal must be able to have two points, and Simpson have 3 points. And the equation of Simpson's is like this. Next. Simpson's rule. Okay, like this.
Like this. Like this one?
This is just mathematical, so I want to
Test.
to change you to write down on your paper to write the equation of Simpson. Okay, finish? Okay, finish. Next. So, I wanna ask you which one is better?
Your method.
The first, trapezoidal? No, you're wrong. The better is Simpson because Simpson have order 2 and trapezoidal just 1. Okay, so the result for our presentation is presented by Wahyu.
solution of this formula is on this section, and we notice permeability in vacuum is for and we assume the Rn of the wire on the extra voltage transmission line is 1000 and
Kecil. Yang belum maju siapa aja?
1000
Yang belum maju. Saya kita ya.
ampere, and R is the distance of the wire to the ground, and use R is 15 meter, because 15 meter is from the government rules from the SDM. And now this current is 1000 and R is 15. Because the wire is so long, we will use, for the real integration is we will use 0 until infinity, but in this method we will use 0 until 100. And we will use the segment is 100 segment of the integration, and no, because this use Simpson, we will the segment must be given. The result is this is a graphic, and using analytical calculation, we get 1.3 10 power minus 5 Tesla, and when we use numerical calculation using Simpson, we get 1.3 power 10 power minus 5, and in this case we will use absolute relative error, not approximate error, because we compare numerical and analytical. And we get 1.5% when we use the integration from 0 to 100, and when we increase the upper limit, we use 1000, and the segment we will 101, we will get this is the graphic, and the error is and the error, the absolute relative error reduced to 0.011%. And we will use trapezoidal. Again, we will use the current is 1000 and the R is 15. First, we will integrate from 0 to 100 and the segment is 100.
Berapa data Mas punya? Berapa data punya? Satu angkat gitu.
100. First, the segment is 100 and you get the error is 1.1%. And when we increase the upper limit to 1000 and the number of segments to 1000, we get the error is 0.01, and this is the graphic.
Nggak kelihatan saya, nggak kelihatan.
Ya, karena terlalu
Semakin itu ya, errornya.
semakin banyak segmen maka semakin rapat dan
Itu satu ya, trapezoidal ya.
this is trapezoidal. And Simpson is
Dalam komparatif yang sama.
oh, pembaginya belum.
Yang belum presentasi berapa ini? Satu.
Satu.
Satu aja ya. Dua. Sudah. Sudah dua aja ya. Yang konfirmasi. Konfirmasi grafik. Satu, dua, tiga. Itu satu kan grup satu aja ya.
Oh,
Satu, dua, tiga, empat. Berarti aku perlu ngesak. Sebentar. Nah, ini gak ada isi kampung. Masih ada yang kosong masih itu mas. Selanjutnya.
Itu masih ada Pak.
Orangnya nah.
Oh, nggak ada ya.
Wah, ini cabut.
Masih Pak.
Masih Pak. Kecuali pada nggak mau dinilai ya nggak apa-apa.
Masih Pak, ada Pak.
Masih ya?
Pak, ada Pak, harus ada. Cabut saya Pak, profil saya juga.
Bisa dinilai atau enggak? Oke, bisa kayaknya.
Kecil. Yang satu kelompok lagi siapa? Yang belum presentasi. Lah.
This is the comparative type of Numerical and Simpson, where we use the lower limit 0 and upper limit is 100. With trapezoidal with the same segment is 101. We get the error of the trapezoidal is 1.109 and Simpson is 1.10. And when we use the lower is 0 and the upper is 500 and the segment is 499. The error is same 0.0.
Gambarnya Simpson. Ini yang kalau trapezoidal tadi 1000 ya?
Ya.
Kalau 1000, trapezoidal 1000. Coba kayak gini kan? Trapezoidal 500 ya? Coba arahnya terus nih. Komparnya kan gitu ya? Ini langsung itu.
Because
Tetap nggak kelihatan. Kalau Simpson tetap kelihatan.
in the trapezoidal, so we the